In this video, we're going to look at application of the quadratic function. In the first example, it says, a horse breeder plans to construct a corral next to a horse barn that is 50 feet long. Using all of the barn as one side of the corral, he has 250 feet of fencing available and wants to use all of it. A. Express area A of x of the corral as a function of x and indicate its domain. B. Find the value of x that produces the maximum area. And C. What are the dimensions of the corral with the maximum area? So the first thing I want to look at is the picture, and we can see that the piece of fence that finishes the side of the barn is x. So that means the other side is x plus 50, and we need to keep that in mind for area. Remember, it's length times width. And here we have a side of y, and we also have another side of y. So there's two equations we're going to need to come up with, the perimeter equation and the area equation. So our perimeter is equal to the sum of all the sides, and we have two y's, so we have 2y, plus we have an x plus an x plus 50, so we have plus 2x plus 50. And remember that area is equal to length times width, and here we have a length of one side of x plus 50, and the length of the other side is y. And now in order to write this as a of x, we need to substitute in for y. So here in the perimeter formula, we know we have 250 feet of fence. So we subtract 50 from both sides, and we subtract 2x from both sides, and this is equal to 2y, and we divide by 2, so we get y is equal to 100 minus x. So here we know that a of x is equal to x plus 50 times 100 minus x. So this is a portion of part A, and then the other part is domain. And remember that x and 100 minus x need to be non-negative. So the domain is 0 to 100. And if we think about this, if x, the little piece next to the barn, was 0, then that means the one side would be 50 and the other side would be 50 feet, so there would be 50 gone, and then both y sides would be 100, and we would have a 100 by 50 foot corral. Now if the domain of x was 100, so then we are 100, and then we had the extra 50, so that means this side is 150. That means we would have used all of the fence with the two sides, and y would be almost non-existent. The two fences would just be on top of each other. So that's the minimum and maximum that it could be. Now in B, they're asking us to find the value of x that produces the maximum area. Now what we're going to do is multiply the two factors of a of x together, so we get a of x is equal to 100x minus x squared plus 5,000 minus 50x. And now I'm going to rewrite it and combine my like terms. So I have negative x squared. 100x minus 50x is 50x and plus 5,000. And now in order to find the vertex, or the x value of the vertex, remember we're going to use negative b over 2a. And that's equal to negative 50 over 2 times negative 1, which is equal to 25. And remember, if x is 25, then the one side of the corral is 75. And now in order to find what the length of the y side is, we plug 25 into y, so we could say 100 minus 25 is equal to 75. So we have 25 is part B, and the other part is to know that the max area is and we're going to come back to what it is. Part C asks what the dimensions of the corral are. And we just found that the y side was 75 feet. And then remember, if x is 25, then we said that x plus 50, because plus the barn, is 75. So the barn is actually 75 by 75. And if you multiply 75 by 75, you get 5,625 square feet. In the next example, we have an arrow shot vertically into the air reaches a maximum height of 484 feet after 5.5 seconds. So we know that one point on the trajectory is 5.5 and 484. And we're going to use this. And then it says let the quadratic function d of t represent the distance above the ground in feet, t seconds after the arrow is released. If air resistance is neglected, a quadratic model provides a good approximation for the flight of the projectile. A, find d of t and its domain. So the first thing that I'm going to do is write what I know. I know the vertex, so I know that d of t is equal to some value of a times t minus 5.5, which I'm going to write as 11 halves, squared, and that is the horizontal shift to the 5.5 plus 484. And now what I'm going to do is plug 0 in for t, and if we haven't shot the arrow yet, we know it's 0 feet off the ground. So here, if we plug 0 in for t, we need d of t to be 0, and then we're going to solve for a. So 0 is equal to a times 0 minus 11 halves squared plus 484. And now 0 is equal to 121 over 4a plus 484, and subtract 484 from both sides and multiply by 4 over 121 is equal to a, and a is equal to negative 16. So now that we know this, we know that d of t is equal to negative 16 times t minus 11 halves squared plus 484. And before we get to the domain, I want to multiply out the perfect square and simplify the equation. So I'm going to say that d of t is equal to negative 16 times t squared minus 11t plus 121 over 4 plus 484. So now d of t is equal to negative 16 t squared plus 176t minus 484 plus 484. So now we have d of t is equal to negative 16 t squared plus 176t, or negative 16t times t minus 11. And now in this form we can see that the domain is 0 and 11 because both factors have to be non-negative. So now we can say domain is, and now in part B it wants to know at what two times will the arrow be 250 feet above the ground. So now we have to say 250 is equal to negative 16t squared plus 176t. And now in order to solve a quadratic, I'm going to move everything to one side of the equation. So I have 16t squared minus 176t plus 250 is equal to 0. And now in order to solve t, I'm going to use the quadratic equation. So t is equal to negative b, or 176, plus or minus the square root of negative 176 squared minus 4 times a, which is 16, times c, which is 250, all divided by 2a, or 2 times 16. And it asks us to round it 2 decimal places. And when we do this, we get 1.68 and 9.32. So at 1.68 seconds and 9.32 seconds after releasing the arrow, it will be 250 feet above the ground. And that's all for this video on application of quadratic functions.